Hello, this is Chuck Ridgway, Automation Technology Manager from Horner. Thanks for joining us for another Tuesday live stream. Well, I'm joining you here today from WEFTEC, which is the Water Industry Show, and we thought it would be a great opportunity not only to talk about water industry type topics, but also to cover a new product that Horner is developing for analog totalizing. And that's a product you would use for maybe taking a flow meter output and totalizing the volume, maybe of a liquid, maybe of a gas, whatever it is that you're looking to do. So that's really what's the topic for today. So here's how we're going to cover that topic. So we're going to bring in Nate Beachey. Nate is our Horner Solutions expert when it comes to programming these products, the Horner Solutions type products. So we're going to have a conversation with Nate. From a real world standpoint, we've got Robert from Frontline, who's out there selling a lot of products in the water industry, flow meters, totalizers, you name it, across the board. We're going to talk to Robert about that. We're going to spend a little bit of time talking in detail about analog totalizers and flow totalizers, how they work, theory of operation, even though as a Horner Solutions product, really all you have to do is plug in the scaling and you're good to go. And then we're going to do a little bit of a short tour of the booth here at WEFTEC so you can see all the products that we're previewing here at the show. Some of them are previews because they haven't been released yet. Others are fully released product that you could buy tomorrow. So that's what's on the agenda for today. Okay, Nate. So last week we talked chart recorder, Horner Solutions product that you were heavily involved in creating from an application standpoint.
Absolutely.
All right, very good. This week we're talking analog totalizer. So what is an analog totalizer?
Well, an analog totalizer, sometimes you'll have flow meters that are an analog signal rather than just a pulse from a flow meter fluttering around past a Hall effect sensor or something. So that analog signal, most likely a 4 to 20 or maybe a 0 to 10, I don't know. 4 to 20 is what this will use. As it comes through, we'll test basically what the level is as opposed to what the level was the last scan. We'll know exactly how long it took between those two samples, and we'll be able to extrapolate how much flow has passed in that amount of time, and we'll add that into an accumulator for a total flow.
Okay, so let me spit this back and see if I get this right. Okay, so we've got a flow meter with an analog output. So for instance, it's 4 to 20 milliamp output, might be proportional to say 0 to 1 gallons or something?
Yeah, whatever the specifications for that flow meter are, obviously there's any number of them out there.
Sure,
Yeah.
sure. Okay, so we're going to take our flow, let's say in 0 to 1 gallons per minute, and we're going to connect it up to our totalizer. We're going to measure that value of flow from the flow meter accurately over an incremental time. All right, and then we're going to kind of calculate our volume for that incremental time, and then we're just going to add those all together to get our total volume, right? That's more or less how that works?
Correct, yeah.
Okay.
Yeah, we're able to very accurately time how much time has passed since the last time we sampled that analog output, or I'm sorry, analog input, and therefore we can, like I said, tell how much time exactly has passed. We know what the input was, we know what the input is now, and so we can kind of, like I said, extrapolate all that into flow over a very exact amount of time.
Exactly, and since that amount of time is very short, the average flow is going to be plenty good enough because we're talking probably about really a few milliseconds, or certainly way less than 100 milliseconds anyway.
Yeah, absolutely, yep.
Okay, very cool. Okay, so that's the analog totalizer as it works today. Now, I understand some flow meters, instead of an analog output, they have a pulse type output. So how do those work?
Right, those will just come in as a digital input, likely a high-speed input, just so we make sure we count every pulse that comes in. And then each of those pulses is the equivalent of a certain amount of flow. And so then we know we've got, this many pulses, then we know how much flow we have because that flow meter comes with a specification of so many pulses per gallon or whatever the amount would be.
Okay, so that's a lot simpler. But in either case, whether it's talking analog flow meter or, a digital flow meter, pulse type flow meter, this product will support them both, which is good. Okay, cool. And as
it'll do both.
Exactly. And as a Horner Solutions product, all you have to do is plug in the appropriate type, plug in the appropriate scaling, and you're done, right?
That's right. You'll configure each channel for whatever it's connected to, and it'll do the rest of the work there for you.
Outstanding. So I'm going to be demonstrating that at the trade show, the WEFTEC trade show, the Water Industry Trade Show. I'll be demonstrating the Analog Totalizer in its current form, but I understand it's not in its final form yet. You're going to be doing some changes there before we release the product. So what are some things that won't be in there for my demo here in a little bit, but that will be in there for the release?
Well, the demo only shows 2 channels right now, and some very basic configuration for those 2 channels. Nothing's password protected, and there's no graphs or trends or anything. So it'll be a whole lot more fleshed out when it gets released, as far as password protected configuration, more channels to actually display, graphs, and more ways to view the data for sure, and also data logging and probably some set points for alarming and stuff.
Okay, very cool. So it's going to really bring in some of those same type features that we demonstrated last week with the chart recorder.
Correct.
And of course, it'll have that Nate spiffiness on the user interface. We can count on that, right, Nate?
That's right. It's going to be nated for sure.
All right, very good. That's a new verb we have here at Horner. You've been nated.
Yep.
Either you've been nated or the application's been nated. We're not sure which one.
Hopefully just the application.
Let's hope so. Okay, thanks a bunch, Nate. Thanks for joining us, and we'll see you again soon.
Not a problem, Chuck. I'll talk to you later.
All right. Okay, here joining me at the show, I've got Robert from Frontline. How are we doing today, Robert?
Doing good. Good show so far.
So far, so good? Okay, so let's talk a little bit about what we're calling analog totalizers, okay? So let's talk about some real-world applications for that, because you're involved in a lot of those, especially in the water industry.
Yeah, that's right. So for flow totalization and for data logging, really where we're using the Horner controllers is being able to have another point of contact if you need local data logging for how many gallons you're flowing. If you need a little bit of local indication for an operator, it's a really good, efficient solution for that type of application.
So there's kind of a couple different levels in terms of when we talk about the amount of flow that a user is going to be monitoring, right? Sure. So some of it is a lot of flow, some of it's not quite so much. So talk about kind of the different scales of how much flow people might be looking at here.
Sure. So on like an effluent meter, for instance, if you have that information going back to the main control system, but you still need something local to capture that data logged information, you can do flow totalization of 1 meter even at a time rather than the whole system. And you can use that information to track and make sure the other systems are working properly. Also, with this controller, you can take that totalizer value and send it via Ethernet IP to a larger network, which is a really useful function. There's a lot of older and newer stuff out there where you may have to have some information transition from maybe a 4 to 20 signal or a pulse signal to something more digital, like Ethernet IP or Modbus or whatever digital protocol you're using.
Yeah, and that's one of the beauties of these products, is that we can accomplish that, do the digitization, and then have it available over Ethernet IP or Modbus.
Right, exactly, and it's a really good product for that. It's a good in-between product where you don't need a full PLC, you don't need a full control system, but you need a little more information than what a standard meter or a standard couple of meters are giving you. So you can essentially land those 4 analog points to this one controller and then digitize that for that network.
Very nice. Well, thanks, Robert, for joining me and talking about some of the real-world applications for the flow totalizing.
Yeah, absolutely. Anytime, Chuck.
Okay, now let's discuss in some more detail some of the things that we talked about with Nate and Robert. So let's start with, what is the Horner Solutions Analog Totalizer? Well, sometimes, as Robert said, this is known as a flow totalizer. And as a Horner solution, this is an OCS-based pre-programmed solution that doesn't require any programming in Seascape. So you simply purchase the product, install it physically, and then configure it from the touchscreen. And our analog totalizer / flow totalizer, its job effectively is to calculate total volume when it's used with a flow meter. And let's start with an analog style flow meter, sometimes called a flow transmitter. And an analog style flow meter is going to have an output, let's say 4 to 20 milliamps, that is proportional to flow, with the most common units being in gallons per minute. So the job of the analog totalizer is to indicate the total amount of volume, which would be the total number of gallons of flow. And then I had an offline conversation with Robert where he discussed the fact that, sometimes you're talking about water, for instance, in gallons per minute, and sometimes you're talking about millions of gallons per day. So, Robert works with some pretty large water systems, as you can imagine. Okay, now let's talk about the theory of operation of our analog flow totalizer. So effectively, it's going to be sitting there continuously, or at least periodically, measuring the analog signal from the flow meter, which of course is indicating the flow rate at any given moment. And then by knowing the flow rate of this sample, comparing it with the flow rate from the previous sample, we know our average flow rate over that time. We know the incremental time between samples. And with those two pieces of information, we can calculate incremental flow. So flow rate times time is going to give us incremental flow. And then total flow is really just a matter of adding up incremental flow, or taking our current incremental flow and adding it to an accumulator value. Now, as we take a look at this graphically, we will show flow rate as graphed on the y-axis. Every dotted line indicates a sample of the analog signal from the flow meter, and every yellow slice indicates incremental flow calculated from that signal, as well as our measurement of incremental time. And then, of course, our total flow is just a matter of adding up all the little yellow slices. Now, in addition to support for an analog style flow meter, this product also supports a digital style flow meter. So a digital style flow meter, instead of having an analog signal, it actually has a pulse output that is proportional to volume. So instead of 4 to 20 milliamp output, you've got a digital signal. So the job of the totalizer at that point is simply to count up the pulses from the flow meter and to multiply that by the flow rate in units per pulse, which is typically going to be gallons per pulse, so that it can display the total number of gallons. So again, whether you're using an analog flow meter or a digital flow meter, this product can support both. And as a Horner Solutions product, it's just a matter of configuring the type of flow meter that you have, as well as your, gallons per minute or gallons per pulse. Okay, now let's take this opportunity to take a tour of the booth here at WEFTEC. Okay, so here we're showing the chart recorder product that Nate and I talked about last week. So this is a product that can be used to replace a traditional paper-based chart recorder. We can support up to 4 different parameters that are measured both on the screen as well as logged to memory cards. We can also support alarming. It's a very versatile product. Again, because it's a Horner Solutions product, you set it up and use it, you don't have to do any programming whatsoever. This is a product that we're previewing here. This is a tank monitor that also can do flow monitoring, and we've got it on the flow monitoring screen here. So again, another Horner Solutions product. If you've got a number of tanks that you want to monitor the level of, or you've got flow meters and you want to display flow rate, for instance, this would be a really good product for that. Again, it supports alarming, data logging with just simple setup from the touchscreen. So here's our analog totalizer demo. So what we've got shown here is 2 channels of totalizing. Each channel has a analog signal coming into it, and it's been scaled for gallons per minute effectively, which would effectively be the output from the flow meter, an analog style 4 to 20 milliamp flow meter. So this unit is measuring the analog value at any given moment, and then calculating incremental flow, and then totalizing it and displaying it on the screen, as well as logging it to memory card. Also here at the show, we're showing off the Canvas OCS, which we'll be releasing by the end of the year. So this is our latest controller. As you can see, it requires C-Shape 10 to program it, and it's got the latest graphics technology available from Horner, along with a multi-core microprocessor for really good logic performance. So we've got a number of demos on here. I'm not going to go through each one individually, but one of the demos we have here is our scope trending, where we're showing basically data sampling at about 50 or 100 milliseconds per sample. I think it's about 50 milliseconds is what we've got going here, showing some fairly high speed type data gathering that we're doing on the screen. So Canvas has a lot of new graphics. One of the new graphics features is a completely new trending, and whether it's high-speed trending or more traditional, once per second, once per minute type trending. So again, we're showing off the new Canvas product here at the WEFTEC show. Okay, so that'll wrap things up for today. This is the part of the program where I remind you that we're here every Tuesday at 2 o'clock, whether it is a pre-recorded video or whether it is a video that's live, but we're always streaming it live, and we have somebody standing by to answer your questions, whatever you may have. If you're watching live, you can give us your questions in the chat section. If you're watching on replay, we can take your questions and comments in the comment section. Now, we've got coming up training in the fourth quarter, so go to our website and sign up for training. Also, next week, our topic is going to be user access in the Horner OCS all-in-one controller. So that's how you can manage user access for an OCS at runtime. It's also useful not only on the unit itself, but also with WebMI. All right, so that'll be the topic for next week. So until next week, let's all get out there and do us some good.